everyone, welcome back to my channel. I'm Miss Merkin and today we are going to be talking about similarity. Specifically, we're going to be talking about similarity between two triangles. So the first thing that I want to do is just talk about what similarity means. So if two figures are similar, it means there's a sequence of rigid transformations. Those would be your rotation, reflection, or translations, or even a dilation that would take one figure to the next. Now, similar basically means that the figures are proportional, meaning that there is some scale factor or multiplier that I can multiply all the side lengths of one of my figures by to get my new figure. So it would either enlarge it, make it bigger, or reduce it and make it smaller. So here, we're going to talk about corresponding parts. We've already talked about this in my congruence video, and if you need some help with congruence as well, I will link that video up in the cards, somewhere up there. But for this video, we're going to talk about similarity. Now, first we need to talk about this statement right here. Triangle ABC is similar to this little tilde-looking symbol by itself, means is similar to triangle DEF. So we have a new symbol here, and this is called a similarity statement. Now the similarity statement tells you exactly which sides and which angles on these triangles actually correspond. So the other piece of similarity with triangles, what it means is all corresponding angles are congruent, but all corresponding side lengths are proportional. Or we could just take the length of one corresponding side length, multiply it by the scale factor, and get the other corresponding side length. So here, I'm going to show you how to read the similarity statement and see which parts correspond. So the order of the letters matters. So first letter is A. And my first letter in this triangle is D. So it means that angle A is congruent to angle D. And I'm going to write that down. Notice the congruent symbol has the little tilde, right, as well, but it has an equal sign under it. Okay, my second letter is B and E. So what this means is angle B is congruent to angle E. Next, I have angle C and angle F. So that means angle C is congruent to angle F. Now I can see which parts actually correspond on these two figures. So, before I do that, let me write out our congruent triangles here. So we have angle C is congruent to angle F. Okay, now I need to look and see which side lengths correspond. So if you notice, I'm not going to use symbols that show that the sides are congruent. I'm just going to color code them because for similar triangles, it's not that they're congruent, it just means they correspond, and once I multiply one length by that same scale factor, it'll be the same length as its corresponding side. So here I have AB, which corresponds to DE. So I'm not going to put congruent in the middle, I'm going to put just an arrow. So we have AB, which corresponds to DE. Okay. And then I have my next one. Let's do a different color. We'll do red. I have BC, which corresponds to EF. And last but not least, I have AC, these last two, looks like a rainbow, which corresponds to DF. Okay, so now that we've gone through a similarity statement, I kept bringing up the word scale factor. So in the next segment of this video, I'm going to go over an example of how you can actually find the scale factor between one triangle and the other, given that they are similar. Okay, so now we're going to do an example where we are using similarity in order to find the scale factor between one figure and the other, and we're going to use that to actually solve for a missing side length. Okay, so in this problem here, we are given that triangle ABC is similar to triangle DEF with this similarity statement here. Remember, that tells us which sides actually correspond on these two similar triangles. We are then going to find the scale factor that takes triangle ABC to triangle DEF, and then we are going to solve for x. So, to find the scale factor, we actually create a ratio of corresponding sides. So that's where this similarity statement comes in handy. So AB corresponds with DE. So I'm going to color code this. AB corresponds with DE. Okay. BC corresponds with EF. Okay, and finally, AC, my first and my last, corresponds with DF. So, I need to make a ratio of corresponding sides. So, since AB corresponds with ED, I need to make a ratio or a fraction with those two sides. Now, I'm going from ABC to triangle DEF. And so what that means is if I look at AB and look at DE, I'm going from 6 to 2. And I'm looking for the number, what do I need to multiply 6 by to get 2? It's going to be a fraction between 0 and 1 because it's getting smaller. So if my figure is getting smaller, I need to do my ratio where it's small over big. So I'm getting a fraction that is in between 0 and 1, making my figure smaller. So my fraction is going to look like this. ED over AB. Now notice I didn't put a line on top of this because this stands for the length of ED over the length of AB. The length of ED is 2. The length of AB is 6. 2 over 6 reduces to 1/3. So my scale factor that takes triangle ABC to triangle DEF is 1/3. Now if I wanted to go the other direction and go from DEF to ABC, I just take the reciprocal. And you can see that I just multiply 2 by 3 instead of 1/3 reciprocal. You flip the numerator and denominator to get a length of 6 for AB. Okay, so we can actually use this to then solve for x. So BC corresponds with EF. So that means that, let's come up with our ratio. So let's go EF, because it's small over big, EF over BC. Okay, EF is x, BC is 12, and they have the same scale factor that takes one to the other, so that should equal 1/3. Okay, This is called setting up proportions that are equal to each other to solve for a variable. So I have x over 12 equals 1/3. So what I can do here is actually cross multiply. 3 times x is 3x, which equals 12 times 1, which is 12. Divide both sides by 3, and x equals, well, 12 divided by 3 is 4. So the length of EF is 4 units in this case. So notice how we have some uses. Once we get that scale factor, I could actually even go through and solve for AC as well. I'm just taking each of these lengths, multiplying them by 3 to get the corresponding lengths over here. To go the other way, I'm taking each of those lengths and multiplying by 1/3 to get to those over there. Now note, I was only able to find my scale factor once I knew that the triangles were in fact similar. In this problem, I was given that they were similar, but in future problems, you might have to prove that first, and that is what is to come. In the next segment of this video, we are going to talk about how to prove that two triangles are similar. Okay, so now we're going to get into how to actually prove that two triangles are similar. So, the main idea of this is that two triangles are similar if all of their angles or all of their corresponding angles are congruent and all of their corresponding side lengths are proportional. However, just like in the congruence video, we talked about how you don't need to know that every single pair of corresponding angles is congruent and every single side length that corresponds has the same scale factor. The only thing that you need is either two pairs of corresponding angles, or angle-angle, similarity. Notice it's not a congruent symbol this time, it's a similarity symbol. Side angle side, which is a pair of proportional, meaning those two sides have the same scale factor, proportional sides with a congruent angle in between them, and side, 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 which states that each corresponding side length has the same scale factor or is proportional. So these are our three theorems for similarity, and I'm going to go through each one of them and give you an example of what this might look like. So if you know that we have two pairs of corresponding and congruent angles, you know that by AA, these two triangles are similar. So it would look something like that. All right, if we had side angle side, it means we have two sides that two pairs of sides that correspond and have the same scale factor, and the angle between them is congruent. So what that would look like is if I knew that this angle was congruent to this, and let's say that this length was 2, this length over here was 3, and this length was 4, and that length was 6. Well, we can see that 4 over 2 is 2, and 6 over 3 is also 2, so it means we have two pairs of corresponding side lengths that have the same scale factor with a congruent angle in between them. For side, 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 it means it's very similar to this, except instead of that angle, I just have a third pair of sides that have the same scale factor. So I'm going to steal those lengths from up here. And instead, I'm going to add, let's see, this here. Okay, so let's see. Oh, this doesn't quite work. Let's go with 4 and 8. Okay, so here I have a triangle with lengths 2, 3, and 4, and a triangle with lengths 4, 6, and 8. 4 over 2 is 2, 6 over 3 is 2, and 8 over 4 is 2. So all three side lengths are proportional and have the same scale factor, so by SSS, I can prove that those triangles are congruent. Alright, so now that we have our theorems down, we are going to actually do a problem in which we are proving or showing that two triangles are similar. Okay, so in this example, we are going to prove that these two triangles are similar by using one of our three theorems that I gave you in the last segment of this video. So right here, I have triangle SUN and triangle RAY, and I'm going to prove that they are similar. Now, just like in the congruence unit, we have to have our corresponding parts match up. So I don't know if these are similar yet, but once I figure it out, and when I write my similarity statement, I'm going to make sure my parts correspond in that statement. Alright, well the first thing I'm noticing is that angle U is congruent to angle Y. They have the same measure. So I have angle U is congruent to angle Y. Okay, well now I'm given these two side lengths here and two side lengths there, and my angle that's congruent is in between them. So I'm thinking that I'm probably going to use SAS, but I can't confirm that for sure yet because I need to verify that the scale factors correspond or are the same to take one length to the next. Now I'm noticing 8, 6, 4, 3. 4 is the larger number, 8 is the larger number, so those probably correspond. So now what I'm going to do is write the ratio. So I'm going to put actually SU over AY, which is 8 over 4, so my scale factor would be 2. 4 times 2 is 8. Now I need to verify that RY, going from RY to UN, we'd have the same scale factor. So I'm going to say UN over YR, which equals 6 over 3, which is 2. These are the same, so it means that these triangles are going to be similar by SAS. So I'm going to say here, triangle SUN is similar to triangle. So we have SUN, we just need to make sure our corresponding parts match up, so it's going to be AYR. And that's going to be by side angle side similarity. Alright, that is all for today. I hope you enjoyed and have a great rest of your day.